Guys, I'm doing angles of triangles. Two theorems we're going to talk about today are angle sum and exterior angle theorem. I know the word "the" is there. I'm going to fill it in. This page is only about the angle sum theorem. The sum of measures of angles of a triangle is always 180. So they ask you to find A. I've done it for you, but here's how you do it. Always fill in your shape. 123 degrees, 42 degrees for angle C. You find 15 by doing 180 minus 123 minus 42. Add them together and they should equal 180. That's the beginning. Now, before we do anything else, I want to show you what this now means. Now that you know this, couple that with the two most used rules in all of geometry. Vertical angles are congruent and straight lines equal 180. With the rule that triangles equal 180 also, we're going to try to do this, what's called a bow tie example. It's called a bow tie example. It's shaped like a bow tie. But you got to use those three rules, and if you use those three rules, you are set forever. Now, can we solve this bottom triangle? No, we only have two angles. Can we solve the top one, angle 1? Yes. Angle 1 is 82 minus 28. Added together, these two added together minus from 180. You get 70. So this is 70. Now, the two most used rules in all of geometry, vertical angles are congruent. This becomes 70 because vertical angles are congruent. Now, do we have enough information to find angle C3? Absolutely. 3 now becomes 42. So that is why these three big rules are so valuable. That's the bow tie example. To get more creative, this is called exterior angle theorem. This theorem is very helpful really only with variables. If you remember those first three things we went over today are the most used rules. This also helps supplement those rules. It adds to them. The exterior angle theorem is the measure of the exterior angles of a triangle is equal to the sum of the measures of two remote interior angles. What's a remote angle? Interior angle, exterior angle. These are the remote interior angles to the exterior angle here. That's why we can safely say these two angles, because a straight line equals 180, are always going to be added up to equal the outside angle. For example, 100 on the outside, 70 on the inside, x on the inside. You don't know if that's 80. You don't know if this number here. You know 100, you know 70, you know x. 70 plus x equals 100. X equals 30. The other way to do it, straight lines equal 180, put an 80 here. You don't need to use this theorem if you don't want to. You could put an 80 here. 70, 80, subtract them from 180. And that is why these are so important. Pictures get more and more creative. Look at this picture. How creative is this? Somebody came up with this picture. The picture of multiple triangles put together. Multiple triangles put together, you can now use all the information we've just gone over, and you can find all these angles. So this looks daunting at first, but angle 1 can be found. If we can find this angle, straight lines equal 180. Well, you can find this angle right here by doing 50, 78 minus 180. Or do the exterior angle theorem, which is just add these two together, and that will give you 128. How do you find angle 3 from that? That's the outside angle. No, you know what angle 2, how do you find angle 2 from that? You do this. Straight lines equal 180. Because straight lines equal 180, you can now do the math. This is 128. This angle here is going to be 52. This becomes 60. You can do the math again. Equal supplementary angles, and this becomes 68. It all starts filling in. This one, vertical angles are congruent. This is 60. Do the math. Exterior angle theorem. Add these two together equals the exterior angle, the two remote angles. Next thing you know, you're all done.